Hello and welcome back to this presentation. We've covered the basic approach to use Training System Lab and the intermediate approach, which is EvoRun. Remember that EvoRun is a multi-run iterator allowing for thousands of trading strategies to be designed over a variety of setup criteria, including any one of 27 trade types, 41 fitness functions, 5 preprocessors spread over 2 different option types for a total of 10 preprocessors. Each preprocessor has 56 inputs. We can also vary bar size in EvoRun and max trades per day. Bar size is particularly interesting using intraday granularity of data, either for day trading or overnight positions held with intraday data. Here, for example, is the same market with 15-minute, 30-minute, 45-minute, and 60-minute data. Notice that the descriptive statistic, the indicator serocorrelation distribution, is very different for each one of these granularities, yet it's the same market. So for example, in 15-minute data, a holding period of 5 or so bars into the future seems to have the highest distribution on a long-only signal basis. Other markets, other time frames like the 45-minute data has practically no profitability going long only, looking at 3 to say 6 45-minute bars into the future. So designing on one of these granularities can have a very different look in the profitability and strategy performance statistics of a strategy. EvoRun would iterate through these, say 15-minute, 30-minute, 45-minute, 60-minute, etc., all the way up to say 150-minute data, and present you with the EvoRun grid, whereupon you can look at and determine which granularity has the highest risk to reward or reward to risk that you are looking for. Now, what we consider to be the advanced approach is to use DAS. DAS stands for Design Time Adjustable Solutions. So you begin the run, and then you can adjust the criteria while the engine is designing, and then ultimately finalize and implement. What is DAS? It allows for altering of simulation and fitness objectives during the run. So we start the run, then we essentially reach into the criteria and adjust the criteria and observe the impact that it has on the design process over time. Now we're using the same procedure of looking at the run logs, determining how learning is taking place, but then we can switch criteria and evaluate immediately what effect that criteria has on the overall design process. That way you don't have to stop, reconfigure, and rerun the design. This provides important human feedback into the design that we've never been able to realize before. I can design time adjust many criteria in DAS. I can not only change the trade type, fitness function, and preprocessors, I can also adjust things like the backward or forward out of sample. So we can begin the design process using, say, forward out of sample, and then while that same learning is taking place, we can switch to backwards OOS or OOS on the earliest data. We can also turn on and off stops or limits. For example, the GP evolved limit exit can be turned on or off during the design process, etc. So it's a very powerful tool for evaluating how our design will be affected by adjusting the criteria during the design. Now, I have two TSL instances that are running, that are available right now. One I started a while ago, 9 minutes ago, and it's just designing on trade type 14, preprocessor 1, and fitness function 1, a very basic design. So here's the setup. It's extremely simple. Now, after I've configured this particular run, I can, one other important thing is this is a EvoRun. So I'm incrementing over trade type, preprocessor, and fitness function. So as at the current time, it has gone up to tray type number 17, and when it gets done with iterating on the tray type, then it will start all over again on the second preprocessor. This run using all three of these criteria, this will take a long time. Now, when EvoRun is running, I can't start DAS. It just won't let me start DAS. It tells me to turn off EvoRun. And that makes sense because if I was running EvoRun and incrementing over fitness function and tray type and preprocessor, I certainly wouldn't want to be able to reach inside the engine and adjust the tray type away from what the EvoRun is iterating to. So EvoRun running will not let you run DAS, but I can start another instance of TSL. In fact, you probably remember earlier demos where I had 20 instances of Trading System Lab open on one PC, and I've demonstrated as many as 40 can be opened on this machine here, which is already a couple of years old. So using DAS is extremely easy to use. We simply activate it and begin the run. Or if we'd like, we can go to simulation setup, say load some settings that I was using on an earlier run, or configure for a run as we see fit, begin the run. Then as the run has begun, I can turn on DAS and begin to play with these controls. So right now we are designing using FF12, TT5, and PP4. But let's say that I want to switch over to fitness function number 4. Well, simply switch over to that fitness function, and at the next run update, when the run update changes and increments the run, we will then begin invoking the new fitness function. You can see over here in this column, we have the fitness function that has been selected and the fitness function that's in use. So right now I'm using fitness function number 4, which is net profit over max drawdown. But let's say we want to switch over to something like, say, strictly percent accuracy. So using number 18, I'm only interested in designing a trading system that has the highest percent accuracy. Nothing else matters. Right now we're at 82%, and perhaps it'll climb even higher during subsequent runs. Percent accuracy is perhaps not the only criteria that I should look at. There's a lot more items involved than just simply percent accuracy, things like drawdown. If I wanted to, I can adjust this drawdown and bring it down to a lower number, say something around $2,000, for example, and still look at percent accuracy. Now, if that's an unrealistic number based on trading constant dollars on this market, which happens to be the QQQ, we simply won't be populating the GUI, and I'll need to change that criteria or eliminate it completely and choose another fitness function, perhaps net profit over square root of the semivariance, number 27. So again, we can now adjust this criteria during the run. So right now I'm using FF27 Trade Type 5 Pre-Pro 4. I can also turn on and off GP limit exits, or any exits or any stops. Let's turn on GP exits and see what happens. So we've turned on GP exits, and now we can see we have a great deal of flat time here. Well, that's not really desirable to have that kind of flat time showing up in the equity curves. So I would need to make some other kind of an adjustment. Force more trading, for example. Let's force some more trading into the system and try to get rid of that flat time. Can also, as you saw, I switched to net profit only. That seemed to help eliminating that flat time. But you can see that we've been designing thousands of trading systems on each one of these criteria to evaluate the effect that those changes have made in our in our design, we can of course pull up the ME grid for this particular PID number, which is 22424. So let's open up that ME grid. And that would be ME grid 22424 here. And of course, I can then sort by out of sample, for example, and sort then again by, say, net over drawdown or Sharpe ratio. And now I'm looking at how good only the out of sample performed. This can be particularly beneficial if I'm working in a particular granularity that has a too small or even too high of an average trade. I can see a bulk set of trading results and evaluate that out of sample here. So this is a very powerful tool to be able to evaluate that. And still, this engine is designing using fitness function 1, trade type 5, preprocessor 4. I turned on GP exits. Let's say now I want to use backwards OOS. So I'm going to use the earliest 20% as the data as out of sample. So this one may take 2 run updates to update and change the out of sample, because I think I missed the threshold for the first one. So we'll wait for the next run update here to occur, and it looks like it just did. How do we know that we're looking at backwards OOS? Well, I can pull up the performance report and look at the begin date. The begin date was 1999, and the end date of the out of sample was 2004. In the training data, the begin date of the training data was 04, and the end date was 2021. All data spanned from 1999 to 2021. So in fact, I am using the earliest 20% of out of sample. But again, we have this flat time period in here, and I don't like flat time. So what might help is to try something like net profit over underwater time, or once again, force more trading activity to occur, perhaps even a larger number like 200. So here again, we can see immediately the effect that our changing criteria has on the design process, and evaluate some rather substantial adjustments to the learning process almost in real time. And of course, as our computers become faster and faster, we will be able to get even more instantaneous results as to how well or poorly our changes how they affect the overall design process. So I'm lowering the OOS down, backwards OOS even further. It's at 7% now. We'll see what happens there. We still have this flat period, and I just don't like that flat period. We didn't have that flat period using forward OOS, so that tells us perhaps that the movement dynamics early in the data back in 1999 were not particularly conducive to this particular setup. So let's go ahead and go back to the forward OOS, only this time I'm going to be using 50% in sample and 50% out of sample. And let's see what happens as we let that criteria become invoked. You can also save the settings for this DAS configuration here, or and load the settings from a file if you wish. And remember that we started in the simulation setup tab. So if we change something here in the beginning of the run, it will show up here in the DAS pane. What I can't do is change settings here. This is only to be set initially. DAS is your tool to allow you to change things during the run. Now, I'm not getting any trades out here at all, which means that my criteria that I've invoked is too harsh. Something is too harsh about my criteria. So I'm going to eliminate that GP limit exit, We'll wait for another run update. And here we are, we're back again, only this time we're running 50% in sample and 50% out of sample. How do I know that? Well, I've got 2,600 bars in the out of sample data and 2,600 bars in the in sample data. So as you can see, it's split basically 50-50. So we can let that run and really see how well this trading strategy is doing using so much out of sample data. That can be a pretty harsh test on this criteria. Normally we would be using 20% or so out of sample data. But despite some rather choppy equity curves, it's not holding up too bad. It seems to be designing the equity curve straighten out. One other thing I want to mention here, for the purposes of this demo, I'm only using a GWI of 1. That means that the trading strategies that are being designed are only being designed through one consumption of the population. And that's so that I can get many runs occurring in a relatively short period of time. For your runs, perhaps on your faster computer, you would set this number higher, say at 3 to 5 in that range. Or if your data allows, set it even higher, perhaps 10. Remember that the number of parameters that are produced in the trading system are roughly proportional to the GWI. So right now I'm designing trading strategies that should have a minimum number of parameters, but perhaps too few parameters. So I may be leaving a lot of performance on the table. If this number is set too high, the run will take longer because we'll take longer to go through a much higher number generations without improvement. But the trading strategies will also have a greater number of parameters, which means that the trade to parameter ratio may become unfavorable. So everything's a trade-off in this business, and we need to be aware of the sweet spots in our data as we do our work. So I'm going to reset that back to 20% out of sample. I'm going to put back on the GP limit exit. I'm going to leave everything else alone here. That seemed to be pretty good settings for the QQQ going long only. Of course, I would have to change my GWI, and we can't change that during runtime. So I'd have to restart the run to adjust that during runtime. Or, of course, I can start another instance of Trading System Lab. And of course, if I'm using multi-instance, I'll want to go File, Open, and open an unused best programs .bst. Also remember the .bst is where our genetic programming parameters are being stored. So when we go Setup Learning, Options, and configure these settings here, and we hit Save, those settings are stored in this .bst. So each one of my runs here has a different .bst. So each one of these runs could have a different genetic programming parameter criteria. Let's quick load those settings. Again, I'm long only, constant dollars, no exit, enter on a limit, net profit over underwater time, preprocessor 4, 20% out of sample, apply the settings, begin the run, and open up DAS. So that covers DAS, and of course, at any time during these runs, I could go back to an earlier configuration, and if I'm not happy with what I'm seeing here, I can reconfigure this and let it run some more. When I stop the run, I have a large list of trading strategies that are available for me, and I can go and use post-design evaluation. Your post-design evaluation in other GUIs is right here in this blank spot. In this particular version, I have it relocated it right there. But that's post-design evaluation. And when I click on one of these programs here, we can see that the GUI will change, and I can then use this to choose the trading strategy to implement. Now, as I drop down in the criteria, I'll need to remember what configuration I used in this particular model. And to do that, we would want to go back to the run log, find this this fitness function, this fitness here, and look at what the configuration was that that applies to it. I did a lot of changing here, and it's easy to lose track of what particular fitness function is being consumed at this time. Something very interesting here, I notice this particular trading strategy that emerged here only used 2 inputs. It's obviously not my best trading strategy on this particular run. So we'll be clicking through here, looking at another one. Each one of these best programs buffers will have a maximum of 300 trading strategies. So we can easily start 10 or so instances of Trading System Lab. So you can see that that's a great number of trading strategies that that we can look at for implementation into code. This one here is very interesting. It's only using 1 parameter. Let's take a close look at this. So this is system number 8424604. 8424604. Without going into the log, I'm not sure what particular setup I used there, but the setup that I did use produced a rather nice looking equity curve here and only used 1 parameter. That's pretty amazing, and should show you the power of this engine being able to design a rather great looking equity curve with this performance here, with only 1 parameter. So we've got let's see, we've got 215 trades and 1 parameter. That's a 215 to 1 trade to parameter ratio. That's quite good. And I have many more trading strategies to evaluate. And again, I only used GWI of 1 for the purposes of this demonstration here, and you would be using a higher GWI. I have other engines running here, for example, this one, and stopping this run will bring up a list of best programs as well that I can then use post-design evaluation to evaluate. And of course, I still have my Evo run here that's been running, 42 runs. We have a lot of trading strategies that are available here for translation. So that should give you a brief rundown on what DAS is. It's a very powerful tool. It's considered the advanced way to use Trading System Lab. You have a lot of parameters that you can adjust in DAS and evaluate. And certainly you can go back and look at an individual run more carefully to zero in even further on the particular strategy that you're interested in translating over to your trading package. Hope you enjoyed this. Thank you. Bye-bye.